all Venn diagrams look like this. Is that what you've always called Venn diagrams? Two overlapping circles. That is what a Venn diagram does. Okay, now we're going to use Venn diagrams to represent categorical propositions. So if you are diagramming a categorical proposition, any categorical proposition, you start like this. So what do you think the circles represent? Subject and predicate, that's right. What are there two of in every categorical proposition? The terms. Now, whatever categorical proposition you are representing, even if it's all non-P or non-S, this circle always represents S, this circle always represents P. Now the reason why I drew this grid is we're going to draw a Venn diagram to represent each of the four types of categorical proposition. A, P, I, and O. But always this is S and this is P. Okay. Tips for Venn diagrams. First, if the categorical proposition is particular, put an X. If the categorical proposition is universal, I'm not going to tell you yet. Some of you will have read ahead, but no spoilers. Okay, so we're just going to focus on I and O. To represent some S or P, I am going to add an X to this diagram. There are four possible places I could put it. You can never, when you are diagramming a categorical proposition alone, put an X on a line. It has to be entirely within a region. And it turns out that a Venn diagram represents the entire universe and divides it up into four regions. One, this little moon shape on the left. Two, the cat's eye, as I call it. Three, the moon on the right. And four, everything else. Goes off to infinity. Where shall I put my X? Now, X represents something. X means there's something here. That's what X means. X marks the spot where there is a thing, at least one thing. Where does my X go if it is true that some S are P? What region? We have a vote for 2. Who agrees? Why?
Because it's both S and P?
Yes, because when you're saying some S or P, suppose I say some whales are mammals, then I'm saying there's something in the overlap between whales and mammals. There it is. Now some S or P means there is at least one. So we'll just focus on that one and put an X on it. But there could be many. Okay? So this is the diagram, and I'm going to take the numbers away because they're not actually part of the diagram. They're just part of my system. This is my system, this number system, and it's not in the book, and it's awesome. So you better take notes. I have got a handout that covers this. Wow. All right. Some S are not P. Where shall I put my X? Be polite now. Well, there's two possibilities of the S circle. Yes, in fact, that's tip number 2. So, tips for Venn diagrams. If the categorical is particular, put an X, dot, 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 in the subject term. So, whenever you're drawing a Venn diagram, whatever you're doing, putting an X or whatever we do for universals, which I'll get to in a second, you're putting it somewhere in the subject term. Now the subject term is always going to be how many regions? 2. because S is 1 and 2. So you know actually, because S is the subject of all of these, is S always the subject of every categorical proposition? No. No, even though it says sub S. Why? Because we've just seen examples where it isn't, like all non-P are non-S. What is the subject term of all non-P or non-S? Non-P. Okay, in that case you would be putting your X, well, no, because it's all. If it was some non-P or non-S, you would be putting it somewhere in non-P. Now you don't know where non-P is yet, but we'll get to that in a second. Alright, so I know it has to be in region 1 or 2. I also know it can't be 2. That kind of narrows it down. Where do I put my X? In 1. Why?
It's not S and P, it's just S.
I know it's S, because we're talking, there is at least one thing that is S. It's S, but it's not P. So it has to be inside S and outside P. So it's region 1. What's that?
What was the sentence?
Some S are not P. Yeah, it's an O type. Some S are not P. Okay? Now we're going to do universal. Slightly more difficult. You shade. You don't throw shade, which is a phrase I've just learned, because I'm old. You shade. And you shade the entire region, but only one region. So you will be shading, if you're shading 1, you will be shading this entire moon shape. If you're shading 2, you will be shading the cat's eye. If you're shading 3, it will be this moon shape. And if you're shading 4, you have to go into infinity, so I hope you've got a big pencil. All right. Here's the important and slightly counterintuitive fact. X means something. Shading means nothing. Well, it means something, but it means there's nothing there. So, when you're shading a region that you know is entirely empty on the basis of the categorical proposition. Let's do the easier one. If no S is P, which of the 4 regions do you know is empty?
2.
Who said 2? Why? Why do you know 2 is empty? What's that? Yeah, so if you say no cats or dogs, in fact you mean there's no overlap between the 2 groups. Well, here you always have an overlap, but so that we indicate that that overlap is empty. If this is cats and this is dogs, what would be in region 2? A cat dog. But if no cats or dogs, there aren't any, so this region is empty. Okay? Well now, you can also work out by a process of elimination where I have to shade for an A type. How do you know it's region 1? Because it has to be in the subject, it has to be 1 or 2, and it can't be 2. Alright, but what's the real reason that all S are P, I shade region 1? How do you know that region 1 is empty if all S are P? All whales are mammals. What would be in region 1?
Whales that are not mammals.
Whales that are not mammals. But if all whales are mammals, how many whales are there that are not mammals? None. In fact, what is the obverse of all whales are mammals? The obverse. Remember, obverse is always equivalent. No?
All mammals.
No whales are non-mammals. All whales are mammals is equivalent to no whales are non-mammals. So this no whales are non-mammals obviously has the same diagram because they're equivalent. There's nothing that is both a whale and not a mammal. So this region is empty. Is that making sense so far? All right. Okay, we're going to go 1 minute over time. At least. You didn't hear that last one. All right. How do we've learned how to diagram the basic kinds, the basic 4. But notice we also have freaky ones like, let's do some non-P are non-S. Oh, before I go on, What is the relationship according to the square of opposition between these two? They are contradictories, which means that this one says the opposite of this one. Why is that obvious from the diagram?
Because there's things in the eye.
Because this one says there is something in region 2, whereas this one says there's nothing in region 2. These two are contradictories. This one says there's something in region 1. This one says there's nothing in region 1. Clearly they're saying the opposite thing. Okay. Now, if two categorical propositions are equivalent, they will have the same Venn diagram. This is the contrapositive of this one. So if they have the same diagram, it means that contrapositive is legitimate for I-types. Does that make sense? Because it means that when you do the contrapositive, you're saying the same thing. Well, let's see. How do we do this? Well, here's my method. So pay attention. It's a great method. There are 4 possible terms. S, P, what are the other two? Non-S and non-P. Each of them consists of 2 regions. S consists of what 2 regions? 1 and 2. P consists of what 2 regions? No. 2 and 3. Well, but if S is 1 and 2, what is non-S? 3 and 4, because non-S is everything that isn't S. And if P is 2 and 3, what is non-P? 1 and 4. Okay. Now, we know from the second rule, I'm going to be putting an X in one of 2 regions. I'm going to be putting it somewhere in, I'm going to be putting an XY, because it's sum. I'm not going to be shading because it's particular. And I'm going to be putting an X somewhere in non-P, which means what 2 regions are possible?
1 and 4.
1 and 4. Now, if I'm saying some non-P and non-S, I'm saying there's something in the overlap between the 2. Right? Because when I did some S, R, P, I put it in the overlap between S and P.
So 4.
So, 4, why?
Because they overlap with 4.
Because I'm going to be putting it in the overlap between non-S and non-P, which is region 4, which is out here. So, is contrapositive legitimate for I-types? No. And we just illustrated that. We worked that out using a Venn diagram, which is good, because it might have been hard to work out just intuitively. Remind ourselves about some things we have learned. For example, okay, so we've learned about categorical propositions. We've learned there are 4 types of categorical propositions. A, E, I, and O. Universal, particular, affirmative, negative. We have learned about the square of opposition, where there are logical relationships amongst the categorical propositions, so that if you know the truth value of 1, you will know the truth value of at least 1 other. What will you always know the truth value of? If you know the truth value of 1, you will always know the truth value of its contradictory. And sometimes you will know the truth value of 3 others. The contrary, the subcontrary, and the subalternate, although not always. Alright, so we learned about those logical relationships. We also learned about what is called in the textbook immediate inference, but which I call functions. The 3 functions that you can perform on categorical propositions: converse, obverse, and contrapositive. Now, we learned about legitimacy. When is a function legitimate?
Like, it's converse or obverse is the same as the original.
It's when the original says the same thing. That's the simple way to put it. A function is legitimate when the resulting categorical proposition says the same thing, conveys the same information as the original. Now, it's easy to work out that all SRP is not the same as all PRS. You can say, you can just think of an example, all whales are mammals, that's true. All mammals are whales is not true. So if one can be true while the other one is not true, clearly they're not equivalent. They don't have the same truth conditions. Slightly harder in the case of contrapositive. So, all whales are mammals, what does this say?
All non-whales are not.
No. All non-mammals are non-whales.
Oh.
Is that equivalent?
Yes.
Yes? Who's not sure? Be honest. Yeah. Okay, so you clearly have a logical gut that tells you that they are equivalent, whereas, but it's not certainly not as immediately obvious as this one. All right, it would be nice if there was a way of working it out. Well, there is, and it's a way that we learned last time. Last time we learned about Venn diagrams. I'll get myself a chair. If I'm going to draw the Venn diagram of a categorical proposition, and I don't even know what the categorical proposition is yet, I can still draw what? Two circles. What about the two circles? They overlap, yes. So two overlapping circles. And I can also do one more thing. Now I don't need to draw a box, I can label them, yes. And always, 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 no matter what the categorical proposition is, whether it be all SRP or no non-P or non-S, always, this is going to be S, and this is going to be P. Okay, good. All right, now, we're trying to work out if all SRP is equivalent to all, what was the contrapositive of all SRP again? All non-P are non-S. Because contrapositive means you switch the terms and then you replace each term with its complement, which is simply it with none in front of it. All right, how do we work it out? Well, they are equivalent if they say the same thing. Well, Venn diagrams pictorially represent what they're saying. So, in other words, if they're saying the same thing, what? The Venn diagrams will be the same. That's right. Now, how do we diagram all SRP? Well, first of all, the very first word tells me that I'm going to be doing what? Shading. Why does the first word tell me that? That's right, because if it's universal, you shade. What does shading represent? There's nothing there, and you shade. How much do I shade? Do I shade an entire circle?
Yes.
No. I do not shade an entire circle. If I shade an entire circle, I screwed up.
Not the middle players.
Well, maybe. I shade one of the elements. Now, I use a system where I number each of the sections. So every categorical proposition has 4 areas. 1, 2, 3, 4. The fourth one, obviously, is everything outside the circles, which goes on to infinity, which requires a lot of shading. If you draw a box around it, I guess you could stop at the edge of the box. So everything in the universe will fall into one of these 4 regions, whatever it is. If this is whales and mammals, then we would fall into what region? If S is whales and P is mammals, where would we go? Well, give me a number. 3. Why 3?
Because we're not a whale, but we are a mammal.
That's right, because we're mammals, but we are not whales. This pen would fall into what region? 4, because it is neither whales nor mammals. So we got everything in the universe covered. And that's true of any categorical proposition. All right. Now, shading, when you shade one and only one of those regions. Okay, 1, 2, 3, or 4, whichever it is. Now, so, just from the first word, I can tell whether I'm shading or putting an X. When do I put an X?
If it's particular.
If it's particular, so if the first word is some. All right. Now, the next thing also tells me something. What does it tell me? It narrows it down to by 50%. So right now, I know I'm going to be shading. So when I look at the first word, I know that I'm going to be shading one of 4 regions. By the time I get to that, I know I'm going to be shading one of 2 regions. Which 2 regions?
1 and 2.
1 and 2. Why?
Because you're talking about S.
Yes, because whatever you do, whether it be shading or putting an X, you always do it inside whatever is the subject of your categorical proposition. Now that doesn't mean it's always S. In this case it is. But in this case, what is the subject? Non-P. So in this case, wherever I'm going to be shading, it's going to be in non-P, which is also 2 regions. And we'll work that out in a second. All right, so I'm going to be shading in either of which 2 regions? What's that?
1 or 2.
1 or 2. Now I have to work out which of those. All right, it says all S are P. Remember, shading means nothing. What region do I know is empty if all S are P? Region 1. That is correct. Why? Why do I know region 1, bless you, is empty if all S are P?
Those are just the S's.
What's that?
Those are just the S's. It's not the S's that are the P's.
And why is that empty?
Because all S's are P's.
Yes, it's if this is whales and mammals, what would be in region 1?
Nothing.
Whales that are not mammals.
Whales that are not mammals. And how many whales are not mammals if all whales are mammals?
0.
0, so that would be empty. Right? Make sense? Good. Okay, so that's all SRP. Now how are we going to do all non-P and non-S? Well, this is where my numbering system comes into its own. Incidentally, I've got a handout that is on the web page. You can get to it by clicking, you go to Blackboard, you click on handouts, you click on handouts for the course, and then there will be something about categorical propositions and syllogisms. So, and that's got the numbering system on it. I mean, you should know it already, but it's not in the book. Okay, what is the point of the numbering system? Well, every term consists of how many regions? 2. S consists of which 2 regions?
1 and 2.
1 and 2. P consists of what 2 regions?
2 and 3.
2 and 3. But that tells us, of course, what non-S and non-P consist of. Because this represents everything in the universe, and the complement of S will contain everything that is not in S. What will non-S be then?
3 and 4.
3 and 4. That's everything that is not S, which is 1 and 2. So non-P is 1 and 4. All right. Now, so what I'm going to be shading or putting an X for this one? Shading because it's universal. All right. What 2 regions can I narrow it down to?
1 and 4.
1 and 4, because I'm going to be shading somewhere in the subject, which is non-P, and non-P is regions 1 and 4. Ooh, it's possible they are equivalent, because one of those is 1. All right, how do I work it out? Well, notice, with this one, I shaded the part of the subject that was not included in the predicate. What part of non-P is not included in non-S? Yes, because what part of non-P is included in non-S? 4. So the part of non-P that is not included in S will be the other part, which is 1. So this is the diagram. Does that make sense? Well, what have we learned?
Is legit.
What is legit?
Contrapositive applies.
Yes, the so contrapositive is legitimate for A types. Fascinating stuff. So yes. Do the rest of them. Now that you know how. So in other words, do diagrams for no SRP and no non-P or non-S. If they're the same, it's legitimate. Yes?
Can you hold up the paper so I can see what? Thank you.
Down to 1 and 4. What do I know immediately?
It's not true.
It can't be legitimate. Why not?
Because the first one was in 2.
Yeah, and neither of those is an option. But I might as well finish. So where am I going to be putting my X? 1 or 4?
4.
4. Who agrees? Why? Yes, because you put it in the overlap between non-S and non-P, and the overlap between non-S and non-P is region 4. So the X goes there, and we learn that contrapositive for I types is not legitimate. Alright, it turns out that contrapositive is the reverse of converse, in that when converse is legitimate, is not legitimate, contrapositive is, and when converse is legitimate, contrapositive is not. Okay? All right.